make sure everyone hears now. Yeah, I think so. Have some difficulty sharing the document, so maybe I put it in a simple format, and then you tell me if it's okay as such, or if I do a presentation mode is better. Yeah,
it's perfect.
Okay.
Yeah.
Okay, good. Thank you for hosting this workshop at the JU. We've had a recurring question about who's who in emotional TT, so it's good to have a few minutes to introduce ourselves. We're obviously several around the table and on Teams, but at least wanted to present who is working in emotional and how the TT transversal topic is situated among the different subgroups with the different topics. So this is indicated in this slide. It's probably not very new for most of you, but again, we've had this recurring question. So we're subgroup 4, transversal topic. Michael is online and I am in Brussels. So what we have in the details of TT is the lead itself. As I said, Michael is the leader of this subgroup 4. But we also have different work packages on the different use cases, the verification of data, the digital twin, the conceptual data model, and the federated data space in the order of presentation from VP 26 to 31 with the names that you see on the screen. So that's us, and why we are having these regular meetings with the system pillar and others is that we have an activity specifically targeting this, and our NRD is responsible for this task, ensuring the right dissemination of results. Also, something that has been confusing to a number of people is why do we use the acronym TT, transversal topic, where it is represented as a workstream 2 in the multi-annual work program, for instance, or a subgroup 4. It's all the same to us, really. So don't be scared by seeing 3 different acronyms. It's us, but it's the name says something about being transversal, is the aim to address topics across ongoing projects, not only emotional. Okay. And the next thing I want to introduce is that we have several ways to describe the data journey in TT. Again, with the representation of the work packages in the different boxes. And what we have is really a evolving yet fairly well reflected organization of these work packages and how they work together. So the CDM conceptual data model is a federation of models, and we will talk more about this afternoon with Pierre, Henri, and Torben here, and all of you online. And it allows for semantic updates and extensions, which is indeed an important topic. And then we have the blue work package, the digital twin, where we have the development and runtime simulation environment that has been developed, and Andreas is leading us through the work and what does modular, interoperable, and composable mean for a number of use cases. A third one, which we will not address today, is the federated data space or rail data space in sorts of red here below, but it's a fairly good triangle working together, these work packages. And I have a question here.
Isabel Carl will address it in his presentation because it is an important contributor to what we are aiming for with the diagnosis. It was a correction because you said federated data spaces is out of scope today, but actually I thought I said we are addressing it.
Okay, we can probably talk about this somewhere in the agenda, but yeah.
It might be an area of cooperation, I think.
Okay, good. And that was about my 5 minutes, really. I tried to go very fairly quickly since it was an add-on, last-minute add-on, but it was, again, a recurring question from that we had.
Yeah, thanks a lot. I think it was very useful to have this introduction. Then I would say we follow the agenda. We have now time until 11:30, and I would like to give the floor to Andreas, and then I don't know how you're organizing yourself, to Carl as well, to talk about digital twin and the use cases of digital twins.
So, okay, I think you see my screen right now, my presentation. So I would start actually pretty fair in the line of Isabel, an overview, a picture from the multi-annual work plan, where the transversal topic is shown in the relation to the other flagship areas. And this applies as well to not only to the complete transversal topic, but only as well to the digital twin. I think all these grant agreements that I read, in particular FA1 to FA4, there are digital twin work included in these grant agreements. And the question is, what is different, or what is the purpose of FA1 in that context? So I would come to that slide. Actually, FP1 motional is associated to the digital enabler 31. And this digital enabler aims to organize and support the assembly, verification, validation, testing, and co-simulation of complex higher order digital twins. And the particular focus in FP1 is to organize modularity, interoperability, and composability. I would like to elaborate on this later. But first of all, I would like to mention one point. Every time that people are talking about digital twins, my experience is that they're talking about something different. Everyone has his own application in mind, and I think it's actually quite natural. I take that picture from literature, and if you look at these branches, these arms, for instance, most of the time the theoretical definitions of digital twins, they address the whole product life cycle. Also, most of the digital twins I saw so far, they are dedicated to a specific period for the design phase or the operational phase. I didn't saw a digital twin actually specifically associated to the end of life period. But you know that's one aspect in which the digital twins in the field differ. Another aspect, maybe the digital model in richness. There are digital twins around that only cover geometrical or kinematical informations, and they goes down to a dynamical behavioral level where even the switching behavior of semiconductor devices are covered. So we are talking about kilohertz frequencies. Or look at the simulation capability as well, a specific aspect in which the digital twins may differ from pure algebraic operations up to predictive simulations. And you can go around all of these branches. You will find different ways of looking at digital twins. Update frequency is as well a relevant topic for verification purposes, maybe certification purposes. We would quite be happy to have models once validated and used. But of course, if you would like to do predictive maintenance or condition-based maintenance, you will have to use connections, informations quite frequently. And they can go around all of these branches. Another point is integration depth. You may have a digital twin on specific dampers, for instance, or on a complete system. So the message here is actually there is no such thing as the one and only digital twin, even it rhymes. So that's what I wanted to highlight here. Another thing is that, of course, a pure simulation model is not a digital twin. However, as we work so far in the work packages, so far we use simulation models to organize these modularity, interoperability, and composability, and it's essential prerequisite to do so. So now, what do we mean by these three adjectives? What's in particular behind? So there are two essential ingredients I would like to address here. One is the functional mockup interface. It's a low-level standard for the exchange of dynamic models that is available. It has been released, I think, in 2010. There are a row of ITEA projects that elaborate on this standard. In the meantime, there are even standard available that is capable of implementing dynamical models on embedded systems called EFMI. So there's a pretty community around that approach. And why do we think that this approach is helpful in the future? There are some specific aspects. One aspect is that in the meantime, more than 180 commercial and open source tools support this standard. You are able to export models from MATLAB, from SIMPAC, from more than 180 tools here. And it means you don't need to implement models completely from scratch. You can reuse existing models. And these existing models, of course, are some economical assets, if you look at that relation. So that is quite helpful if you can use models that are already major, already used in practice, where have no advantages and disadvantages at all. The second thing is that the functional mockup interface is capable of exporting, or it describes the export of binary code as well. So yeah, of course, describe the interface in order to communicate in that scheme here, but you don't have to present the ingredients of the model to maybe to competitors or to the public, and it allows for IP protection. You don't need to give your know-how out of your house. And the functional mockup interface is actually something what I expect to be, let's say, it's actually mandatory. It's for instance, it was a demand in the call of Motional that we. Another thing is that I would, which is a thing I would. It's an option to use it. It's a distributed co-simulation protocol, because it allows the organization of higher order digital twins with more components, and you don't have to present or to transfer your models to somewhere else. you just may include it in a distributed environment, and you're only communicating input and output information via the web. So that's a different kind of IP protection, which allows for co-simulation complex higher order digital twins. And there are already tools available. DIL-A as one, EVL Model Connect is another one here in this field. Okay, then let's come to the general approach. How is your general work screen in work package 2829? The call, if you look at it, asked us or requests to arrange a digital twin support environment, design time environment, and runtime environment. As regards runtime environment, actually we can refer to off-the-shelf products. If you look back at this ingredient function mockup interface, function mockup units, you can use these models defined accordingly to run them, to simulate them on premises in your MATLAB, Simpec, Modelica, wherever you like it. It's one option. You can use software simulation as a service via cloud. That's the environment that I just introduced via distributed conversation protocol. And you can even use it on the edge, on the vehicle. For instance, if you like to aggregate sensor data, you won't communicate sensor information every millisecond. Maybe you would like to communicate only some aggregated information with the vehicle, and there is another option. So that's on the usage during runtime. But the actual work in work package 2829 is here covered by that green box here. We would like to offer two repositories, or one repository with two branches. One repository containing what I could call minimal models. What I mean by that is actually what we like to organize is more complex architectures, and it's important to have this architecture defined in respect to the interfaces, so that for instance, if you look at a more complex vehicle design, there may be one subcomponent, the brake system, and I'm not that interested in the ingredient of the content of the model of the brake system. But it's important to define, to standardize to some extent as well, the interfaces to which this brake system communicates to the vehicle system. So for instance, the minimal model of the brake system may just use input information as the driver input and the output are torques applied to the wheel sets. And the ingredient of the model actually just defines and may define a algebraic aggregation between input and output. But important is that you are able to exchange a model from let's say from Knorr-Bremse against a model provided by Wabtec, just to name two companies in this field. And then would like to combine these middle models to architectures. Here, one example proposed by CAF. We're working on a braking digital twin. We would like to present, to publish this environments via the system pillar GitLab repository, because we saw that that scheme where the TT is requested to cooperate with flagship projects, And our way to do so would be to offer this GitLab repository to other contributors, to other users throughout the EHU. Of course, we think there will be proprietary instances of these models as well. The related associated members may contribute these instances to that GitLab repository, or they can decide to do not so. We'll see. But now I would like to come to what is the use case, the digital twin use case later. We would like to organize these as a part of the Rail data space, where we could provide algorithms to operate on data as well. And in the context of the Innotrans, with my group, I tried to give a practical example, a mock-up. How could that work? So let's have a little video on the Rail data space and how two parts are presented here. That's a data store and a fake app store here, just to show how it could be combined. First of all, we look for some data from Axelbox accelerations, and for preparation of the Innotrans, the DB has organized some acceleration data from Axelbox accelerations, which are offered here, and the potential user of the Rail data space may accept the policies to which DB has published this data. Then we may change to the App Store, where different algorithms may be offered. The particular algorithm here is we're taking this Axelbox accelerations, and calculate back in order to estimate the quality of the track. And as soon as we have accepted the policies here, we switch to an application. We load the data that we have accessed before. Then we have options to set up the algorithms with respect to parameters of the algorithm. And as soon as we run the analysis, we get, as an example, such a color-coded map that represents the track quality. Red hotspots indicate high irregularities. We may review some of these track sections in more detail. For instance, we are now reviewing the first track section. We see now a little graph. The curve here presents an expected evolution in time. The data points are past analysis points, and here you see, okay, the quality is still quite good. No action required here, and now we access another track section, which is different, of course. We have the last measurement shows pretty high value. So here, this track section may need some maintenance actions. But that is a video that we have made in order to present how we could imagine to use data, and how we, that's the offer that we have to data users, how they could introduce algorithms and work with them. So now would like just a little overview on the use cases that we have selected in FP1. For instance, there are two laboratories included in the work packages from CEDEX and DLR that are hill environments in order to test, to certificate onboard units for train control. These two laboratories as well have work to do in FP2 and FP6 as well. A pre-assessment of future ATO setups is an extension of these laboratories at the DLR. Then there's one contributor from SysTech, DB SysTech, who try to analyze databases from past maintenance activities in order to learn about how to organize the maintenance in the future. There's the braking and traction virtual certification digital twin, mainly where DLR and CAF work on. There's Thales or Hitachi is looking at specifically at the point machine of switches in work package 10 and 11 of FP3. There's a pretty ambitious consortium active that looks on multiple sensor information around switches. Then we have two contributions that are related to BIM modeling, and we have from WAPTEP HVAC digital twin, which is related to FP3 and FP4. Just an overview on the use cases. We may see a little on details later. I know the problem is, of course, that the complete architecture, railway system architecture, is quite heterogeneous, and we can only look at some spots here. And that's, of course, a risk. It's a challenge to organize a common framework for these many diverse use cases. No doubt about that. Would like to show current activity. You know, we have the new lead of work package 27, and I was Vasem contacted me, and he asked me to write down a specification of what we expect from infrastructure information. So far, we work with Baltic network data that has been prepared by Traffic Circuit and VP27 as well. But I would like to point, I started to write this specification. For me, it's a working document, a part of the deliverable 29.1 due to month 40. So it's a document where we work with, and everyone is asked to contribute to if he thinks he has available input here. Currently done. Then a thing that to be touched today, of course, is that IU 22 request and the current status of the work package 29 is that we have these two deliverables prepared and submitted. I think they are already accepted. And the work package 29, which covers the actual implementation of the digital twin environments, started in November. The elaboration on use cases is in progress. I could present some details later. And right now, we are trying to organize a collection of harmonized templates that should be made available throughout the joint undertaking. Verification and demonstration is, of course, an important topic for the presentation of the final results of the work package. CAF, for instance, will be active there. CEDEX with their laboratory will be active there. The integration of the digital twin in the rail data space has to be prepared, and we are communicating with other work packages in FPX on digital twins. So that's the introduction I would like to give on the work packages 28 and 29 so far. So how long did that take?
Yeah, then thanks a lot for this presentation about digital twin. Maybe before we continue, since we still have quite some time before the break, are there questions or remarks to this first part about digital twin?
Hello? Okay, yeah. Andreas, in the beginning, you were talking about this FMI, the interface specification. Is it going to, I forgot to ask, is it going to come out of FP28, this interface specification itself, or it exists already somewhere that we can just take and adapt?
No, the functional mockup interface specification is quite general.
Yeah.
It's used in the automotive industry. It's used in aircraft industry, and even energy supply use it. So it's very general. It's just organizing. It organizes the usage of a model component as a part of a more complex simulation model, and it's actually general.
Okay, but we're not going to adjust it for railway use cases, right? Or we're just going to take it one-to-one.
The specification itself,
yeah,
I don't think so far. I have no need to change that with respect to rail requirements.
Okay,
it might happen. That won't be a problem because the chairman of the Modality Association, which is actually organizing this functional mockup interface, is a colleague of mine. So I would have a direct communications line to him.
Okay.
But so far I don't see the need. But maybe it comes.
Yeah, because the reason why I asked is because Carl is going to show this equipment model later and the rest, and I'm just trying to see if the interface specification of the FMIs, if they are similar or they are completely different, or they're talking about different data, because the attributes or the parameters that we have in the equipment model, I would assume since their component also should be similar. Yeah. Have you seen the equipment model from System Pillar? No.
Well, the functional mockup interface allows you to define the interface.
Okay.
In a quite general manner.
Okay.
So actually, what you're defining is the parameters of the submodel, the input, the output information. In the meantime, you can even organize terminals, so a collection of a bus system of more than one collection of input and output information.
Yeah.
So this is a layer of the specification that actually does not really don't need something specific for rails, I think, so far.
Yeah. And you heard about this input-output buffer interface specification? It's like a model because I was reading because these components, the electrical components, they're made of metal and electricity. And I was checking somewhere, and there is this EBIS model. It's called this input-output buffer. It's also used to simulate the states, and from what I heard, it is kind of I don't want to say the go-to, but for most computers, like for RAM chips, for example, they use it to prevent losing IP. Like they will not describe the internal; they'll just describe the input and output. But I heard that it's a very good representation of the digital twin of the RAM, because if you have a RAM in your computer, you cannot see it if it's damaged, right? So, or if you're installing it the first time, so you only rely on this simulation to assume that it's correct. And if you put it on your board and you power it up and it doesn't work, then it's difficult for you to check why it doesn't work. So you've not heard of this model, this EBIS model, no?
No.
Okay. Right. Okay, yeah, that's all. Don't worry. Thanks.
Any other questions or comments to this presentation from Andreas? Yeah, otherwise I would propose to follow the agenda then and come to the next point, which is also about digital twin, but focusing more specifically on use cases, why and where are digital twin useful, what examples have been implemented, and how it is integrated in the architecture of the railway system. I don't know how you will organize yourself, Andreas and Karl. I'll give you the floor.
Yes, so probably Andreas can continue.
Yeah, it's
would
more or
be-
less. I just started to go a little bit more deeper in the use cases that are already mentioned, and give some examples here. Already mentioned here the two laboratories from CDX and DLR that have running environments in order to validate and certify onboard units. Of course, we don't expect that they will change their complete environment as it runs today, but they will use the functional mockup interface unit for things that they will need to implement newly, actually, and they will be used in one demonstration in FP6. The pre-assessment of operational RTO setups is one thing I would show in more details, braking and traction treatment as well.
Sorry, just one short question.
Yeah.
If you go back, I see this ensuring interoperability between different components. And they're not following the standards, then there shouldn't be problems, right? The open issues in the ERTMS digital twin. Second, as if you go 3 columns to the open issues, yeah, where the mouse is now. Yeah. Are they going to be using standards? There shouldn't be problems, right? If they are using the ETCS standards.
Actually, you should ask these on ETCS standards. You should ask the contributor of the use cases, the owner of use cases. Maybe is Michel in the line? Do you hear?
The culprit.
Do you, Michel? Could you say something about ETCS here?
Michael, are you monopolizing ETCS there? I'm not sure if it's there.
So just an observation on that. I understand where you're coming from, but just to give the perspective from the telecom world, which I'm very familiar with, ETSI in particular is organizing plug tests around M6, the mission critical communication framework of 3GPP. So there is a standard in place, and they are doing plus tests because indeed interpretation of the standard is the issue. Sometimes when you actually apply the standard, there's still room for interpretation, and so you discover issues. So I think in theory, if everybody implements the standard the same way, there is no interoperability issue. But it's actually quite critical to give a playing space for stakeholders to actually do this interaction between their components using the standard interface together, because that's where sometimes they discover that they have a slight misinterpretation or different interpretation between vendors, and then in the 3DPP context or in the ETSI world, it is fed back into the specification so that it's adjusted and corrected.
Sorry, can I? If you go back to the first slides with this, the first use case on ERTMS, I'm not quite sure to understand what's the difference with what is currently done by the labs that are involved in ETCS testing, the certification versus against subset 76. And SEDEX DLR are part of it, and there are a few other in Europe. So, I mean, I understand the need to do it, like Pierre just explained. This is normal, but I just don't understand what's the novelty here. I might have missed something.
Novelty is here that
You have to use the mic.
these laboratories have their own setups. It's specified, and they work on their own community and runs. Yeah, but it's not at all modular. It's not at all operable. It's not at all comparable. The point is we have to organize the digital twins in the future in a way that no closed jobs are still there. We have to organize the components in such a way that they can be exchanged. And this is not given still. CDX and DLR, they want to exchange components and collaborate together. So far, these environments are more or less closed jobs. They work, of course, for a specific purpose, but they are closed. Yeah. And my job is actually to organize the modularity. That's the
just maybe to
let's chill a bit. I'm just. I'm not going against you, Andreas. I was just trying to understand what was the difference with what is currently done, and you answered. So let's continue calmly and take a glass of wine.
Just one comment. So it's passionate, Andreas. The thing is,
excuse me, please.
So he cares about digital twin, as you say. And so do we. The point I was going to make is actually also to draw from my telecom experience what we foresaw. So we have similar setups. And one of the challenges we had in the past is that usually when you wanted to do interconnection of systems, you were essentially doing some form of VPN. It is actually more complicated than if you can actually deploy, I would say, a digital component that you would actually make available for other people to test against without you intervening. I think that's more or less one of the reasons why this is bringing maybe not a complete revolution, but a bit novelty into facilitating putting those tests in place. I think it's more in the incremental updates to make it easier for things to take place without too much setup and intervention, I suspect.
My understanding, the wish since 30 years is very well summarized by you, but no progress is visible.
Yeah.
Just one more question, Andrea. Sorry, I don't want to put you on the spot. I'm just looking at this ATO open source simulation kernel. To what level? Because if I see the word kernel, I'm assuming you are going down to the hardware, like you're going to. I don't want to say. You're going to talk about it later.
Well, actually, I'm not that in that detail here.
Okay.
It's just some slides I collected from use case owners here.
Yeah.
The idea here is that they would to like to set up new RTO setups, and they would like to use the environment that they have so far. For one instance is to use cameras in order to verify the setups. I can't go into too much detail. Details here.
But do you know if the output? Yeah, because they're using camera sensors now. Yeah, and I see also LIDAR, see radar. Will the output of the work, because it says open source kernel? Yeah? So I'm assuming. Does it mean that the output would be kind of free out there, or is just something else? Because if you are creating an open source kernel, that at least for real use case, that means you intend to share it out. I just want to know if it's going to be open, because at that level of at the kernel level, then you deal with a lot of hardware. For example, the camera sensors. I'm just an example now. A Sony camera sensor and on semi-camera sensors, they have their particularities that a bit change. Even the naming of some parameters, for example, H sync, V sync, or something else. So it get a bit more difficult on that level. Do you know if they will go down to that?
I would try to motivate every use case contributor to contribute to that GitLab repository and put there at least a simple version of their work that they do. Of course, you know all the
issues
as well. The companies or the use case owners, they have invested a lot of own money, so I can't force them to open everything to the community. But what I would like to motivate them is to put a simple version on it that is that help to standardize that somehow. That's all that I can do so far. I try to do my best in that case.
Okay. Thanks.
Back to use cases that I do personally know a little bit more, but a little bit better actually, is that the use case with CAF, for instance, where the CAF has initially presented that architecture, which is actually pretty detailed, that assumes adhesion conditions. You need a description of the real rail contact. You need to know about the track topology here. And the first implementation looks like that on the right-hand side here. And we are about to detail that
Sorry. Where is the microphone?
The CAF has introduced data on that this EMU here. We provided the vehicle model. CAF provided the specification of the control units, including wheel slide protection, and verified the results so far. And these results will be verified by track measurements in the future as well. Okay, another example is from slides from Uptech, who are organizing a digital twin in order to monitor the behavior of HVAC units and driver cabins. Just some pictures of the models and results here. This is an example from my own group that I introduced since there was, I think, Ralph. Ralph mentioned the important point of certification of vehicle dynamics in the future. My group is working on a new running gear without wheel sets, with independent rotating wheels. And of course, this system will be very difficult to be certified due to safety reasons. And we use the infrastructure around in order to develop the control software in such a way that we can validate it against reality. The example of the approach here is that we are able to jump, let's say, from -6 to +6 millimeters in the track, for instance, by external control. So that's actually overview on the use cases. that are on the table in the work package? I apologize actually for some if I has went too loud or too sometimes yeah, just apologize.
Yes, thank you very much. So according to agenda, we have time until 11:30 for this digital twin use case topic. I don't know, Carl, if you are presenting something, otherwise we can also have a discussion or talk about possible collaboration in this field. Yeah, I see.
Yeah, I would
There's a
present
presentation planned.
also something. So probably for all, good morning, everyone. For everyone who's probably not knowing me, my name is Carl. I'm leading in the TCCS, the SD2 and SD3. SD2 is on diagnostics, and SD3 is on the configuration. And today I will present what we are doing specifically in the area of diagnostics with digital twins. It will be a little bit more specific, and I can also show real-life examples of that. So starting out, so we are following this SEMP process, which might be known there, and we started with an operational analysis, which means we need user stories for our digital twins, and I will not go through each and every one since we are already running late in time. So there are some which are on the operational phase. So it's more or less concentrated on people or maintainer doing the fault clearance service. So they are in the field and doing something, or in the vehicle doing something. And the idea is that I, as a maintainer, that is a role here, need standardized physical and logical models for use, and then the use, those which I will present in details, are written bold here, so that I can quickly grasp the situation with the system without needing to obtain any information from manufacturer-specific documentation. So probably, as you know, there are many components in vehicles or trackside infrastructure, and you don't want the need to read everything or to have it manufacturer specific. So you need to know what is happening in the field, and this gives you a need for standardized models and semantics. I also written here now error ontology. I think for some of those models, I think we need to adapt those semantics, and models and semantics are quite near to each other. So they have a really big relationship here. Probably also another use case is here that the operator wants the use so that I can estimate the operational impact of a faulty product group irrespective of manufacturer-specific structural CS set. Let's say you have a switch in the field, and the switch is failing. Then it would, of course, make a huge difference to you if it is an entry switch for a station, or if it is a switch somewhere down in the field. Yeah, so you probably would like to return to work on the entry switch first, and so that you need the dependency. You need lots of context which switch it is. So not each switch is the same, but you can read the data from all the switches, and together with the context information, you can say exactly if it's a very important switch or not. On the tactical area, which is something like maintenance planning, for example, you would like to have, as a maintenance planner, as a role, also standardized physical and logical models. so that you can have standardized diagnostic messages with standardized semantics, so that you have an entry point. So if you get some information from the field, the question is, does this information mean that I will create a maintenance task sending someone into the field or sending someone to the vehicle? So if you're standardizing this kind of vocabulary, then you know, okay, this is meant as such. I have a problem, I have to send some, I will plan for maintenance. And if I have all the context, I can probably also schedule which is to be repaired first. Then, of course, for the maintenance planning, if you can plan for a longer time, so if you have components that have a wear reserve, so you can just avoid things happening, and so you can plan to repair before they actually fail. What I already mentioned, so you can prioritize fault clearing dynamically due to asset condition and environmental data. Then we have other strategic use cases. You can very much reduce or you can use the knowledge that you have in your company if everyone is able to understand the meaning of the data. That is also a lot to do with training. So you don't want to have a training specific for specific supplier assets. You would like to have a generic vocabulary from the diagnostic data you're getting from the field and you're using them. And so that is really much allowing an operator to not have specific training for each and every component you're buying. Another important thing is that we had this is something I can report from DB InfraGo. If you have different sources of the truth that has been built into the field, then that is a problem. Something is hidden in PDF, something is already in specific formats. And the idea here is that you get the single source of truth from the field. So the current state is what is built into this kind of digital twin here that you then can really read from the field, and everything that is built in can be read from there. In the past, the leading systems were asset management systems. So the serial numbers you were having in your asset management systems, that were the leading systems. And if you can read this information directly from the field, then the asset management are configured by what you have in the field. And that is also an important role we are having from the digital twin here. So, so we need this kind of physical digital twin model, which means physical that you know there is a component that has subcomponents and subcomponents. That is a physical physical model here. We call this model an equipment model. The physical component has a material, which is the type of equipment. So you go to the shelf and have something from that material to repair something. And then you have the component itself, the equipment, that has a serial number. There were lots of use cases we were having that, for example, an equipment has been built out from somewhere, refurbished and put in somewhere else. Or you have some sort of equipments that you have in different kinds of other top-level equipments, and there you really get a clear view where are the components. For example, if you have a charge of faulty components from a supplier and you need to find them into the field, you are happy to know each of the serial numbers and where it is built in. And this is what this model can do for you. It is just having a digital twin of the physical model with serial numbers in it. And as you can see, there are parent-child relationships, and that is also a hierarchical model. There was a question.
Sorry, yeah. I just want to ask Andreas a short question now. So Andreas, if you look at the screen, you see that we have material MDM, we have equipment on the other side. Now, this information, as Carl rightly described there, I would say this information are more in the, production part. Does that mean if you're using the FMI, there will be a layer below this level of information, or are they the same?
Let's say FMI. Actually, if I talk, I'm a simulation guy. If I talk about simulation and modeling, I mean differential equations. So and that's the core of simulation. They have a part, maybe thermal model where I have input heat stream, output temperature. That's my world. Let's call it that way. Yeah. Here, of course, these are still. It's not unimportant. It's very important, but it's actually information on the asset management information, basically. Yeah. And that's a different. Of course, you can contribute or define a functional markup unit in such a way that these information are still given there. No question about that. But the basic idea is we have to organize a simulation of a component.
This is only one aspect. This is the aspect for physical asset representation. And of course, it has an interface to the asset management system. So now you're able, if you have an asset management system, to read the structure of your asset directly from the field as single source of truth. If you exchange a component of that, then you would see the new serial number showing up. So if you have, for example, a 203 computing unit and you're replacing one of the computing units as an exchangeable unit, then it must be an equipment. Then you will see that the serial number is going to change. And probably it will show up in another asset when you refurbish this unit or you have repaired it and put it somewhere else. And that is one of the perspectives that we use for a digital twin here, but it's only one perspective. I will come to the other perspectives on the next slides. This equipment model, that is a base model. As you can see, there is a serial number, there is a material for the type of equipment, there is information about the manufacturer, the model, you have an overall status that is cascaded through the hierarchy of that model. That is something like a building block system, if you want so. So we don't want to prescribe how a supplier is doing his system architecture, whether he is doing one. So if something fails, you replace it as one. Yeah. So if your level crossing is failing, you're replacing it as one. That is something you probably will not do. If you have this breakdown structure, then use the parent-child relationships and you can build up your structure as it is being built, and you can create types of that, and then these types can be instantiated. I will show that later on. So that is the base model for the physical representation for a maintainer, for example, coming back to our use cases, bring the right part to repair something. I know this equipment of that material has failed. I go to the shelf and will come exactly with a replacement unit from the same material. And then this new serial number will show up in your asset management systems connected to it. We have in these kind of equipment some standard components, and these standard components are already modeled. For example, for a controller, which is a computing unit or physical network interface or storage medium, especially for flash ones. We have power supplies here already modeled, physical outputs, physical inputs. So this is something as standard components that you can already use to depict your equipment. And if you don't find something, then just go and use the equipment itself. So what we are also doing on the generic level is that we are able to model redundancies. And that is a very broad concept. So there is a redundancy group and a redundancy status. And you can add the redundancy status to each of the equipments if they have redundancy. And then you can say, is this part, is it available? Is it active? And then they are referenced from a redundancy group. And then you say, I'm referencing at least 2, otherwise I wouldn't have a redundancy, of course. And then if you are referencing, for example, 3 of those redundancy status connected to equipments, and the redundancy group says minimum available is 2, then you have modeled a 2 of 3 system. You can apply that for storage. You can apply it for computing units as a safe computing unit. You can apply it, this concept, for networks, whatever you have. For example, if you have the raster protocol, that is also something like redundancy here. And so this is a generic concept we can depict here. And I think I've already put in these examples so far. So this is how this is modeled then. Then now we have another digital twin model, and that are the logical ones, which are more or less telling you the operational status of a logical component. Can I produce? I have a switch in the field. I have a level crossing. Is it operational? Can it work? So that's a different perspective in our digital twins. And we have digital twin product group models. That is how we call it for each product group. The product groups are mostly then oriented at the supplier structure that you're having. For example, if you are on the vehicle side, you would have probably a door system. And then you have a product group for a door system describing it. This is an example for a switch from what we have done in the ULINX task forces. So I think it looks a bit complicated, but it is not. So it is a field element, and then you have a point. I think now in error ontology, this is a switch that has to adapt, I think. Then we have the point or the switch here, which has a movement status. It has a current position, position degraded. You see lots of enum types here. It has a turn counter, so how often has this point being turned? The last commanded position, and so on. I don't want to go into the details here, but there are experts which are coming from the maintenance field working together in defining such a model structure. What do we need for maintenance to see if this switch or door system or whatever it is it working? Is it working in production? And so this is something that is not generic, as for example, the equipment model that you can use for each and everything, because it's just a breakdown structure of your physical architecture. That is generic. This one is specific for a product group point, for example, or level crossing or light signal or whatever you have. And we also have here point turn events. So sometimes you need to put together information for a point turn. So that is normally lasting 4 or 5 seconds. And then you get, for example, the power you need to move from the left to the right, and then vice versa from the right to the left. And after all that data is being captured, moving to the left, moving to the right, then you define, please collect all that data and send it to me as a point turn event. That is useful also for motor start events or level crossing usage events or whatever. And you can compare what is happening now between what is happening, for example, in a few months in different or similar circumstances. So that is a point turn event here. And yeah, it has that data on the motors and with a very short rate, or you can have which power you probably need to go from left to right or vice versa. So that is an example of such a logical model, or we call it product group models. There is a question. Joaquin.
Yeah, hello. Just a brief
Hi.
question. Thank you for the turn. It was just that we have seen that we are always considering the existence of a physical digital twin model and a logical digital twin model, but I assume that is for the case in which we are trying to reproduce in the digital twin world the behavior of an existing element in the physical world. Is that going to necessarily always happen? I mean, are we going to maybe also produce a digital twin for something that still doesn't exist in the physical world, just to simulate what, for example, a new type of element for the infrastructure would what behavior would it have, and if it is well worth developing it in the physical world? Would that also apply? And then we would have only a first need of a logical digital twin model just to simulate an hypothetical element behavior?
Well, currently we have a lot to do with real existing logical elements. So we have a model for I/O, for ATO, for switch, for light signals, and a lot more. And you can also have these for vehicle side, for door systems. This breakdown structure, so the partitioning into these logical models, that is something that you have to do in the first place. So do I have such a system? And what you're asking probably is going even further, so that you probably think about a new component, and then you can simulate what is the behavior of that. I think that could be applicable. If you have it here, that was a very long discussion in the ULINX task forces for each of those attributes you are seeing at point, because it might be that you need a sensor, and that sensor is costing you money, and you probably, do you have a use case for that kind of data point? And so we have very long discussions there for each of those data points. And I think the list of product groups we need to model is quite a long one. Now I have 3 questions. I haven't, so I think Ari, you first.
Yeah, thank you. You raise the issue about logical versus physical, and you use the term models in the plural. This is where I beg to differ, because you are absolutely right in one thing, that is, we do have a logical thinking level, so to say, and a physical one. And I would even go further. For instance, in the case of rolling stock, it's quite obvious. You have the logical, no, it's no longer appropriate. let's say you have what the manufacturer produces. There's basically a specification and a type that is registered by the agency, by the way. And then you have what you would call here the physical level, that is the individuals that are manufactured according to the type, and that got a certificate at some point and maybe lose it later on because you modify them. So these are all two levels already, and there's a third one, which is the, I would say, the requirements layer. That is, usually when people run trains, they say, I need a second-class coach, I need a first-class coach, and I need to assemble them. And who the manufacturer is and what the type is precisely becomes second order. So there might be even a third layer when you do operations that is neither your logical or your physical layer. Plus, physical is anyway misleading because the case you deal with here is tangible assets, material assets, for instance, like a switch. But also it could apply to immaterial assets, for instance, like a message you produce according to a certain format at a certain time, which is an instance of a message type that you define elsewhere. So this distinction between logical and physical, that by the way reminds a bit too much RDBMS, is in fact pretty much universal, needs a pretty consistent handling, and not in distinct models, but in one model, because of course the logical and physical are linked. For instance, a passenger coach in your inventory has been manufactured according to a type that also exists. It's not material, but it exists in the ERA TV register. So this is, to me, one model and different aspects, which for which I'm still looking for an expression that we can all share when we want to express what you just said, physical versus logical. For the time being, I don't know how to call that, but this is pretty universal. By the way, other models, thinking, for instance, of IFC, also have this distinction introduced in a systematic way, with a functional, a structural, what they call structural is more or less catalog, manufacturer catalog, and the physical layer. So again, this is a universal pattern that applies inside the model because you need to describe the relationships between these aspects. So it's not outside of the model, it's inside. And then, of course, when you practically use a model, you will privilege the one or the other aspect according to your use case, definitely.
Yes, I'm with you. It would have been my next slide in setting up the relationships between the models. But you're absolutely right. They will be in one model from what we get from the field, and we have references between all those models. Let me show that in a minute, but that's right. Yeah. So next one was Torben.
Yes, thank you. I think I have the same question as Eri, more or less. So it says here on the bottom, source PTC model U-Link. So is that the same model as the system pillar CCS TMS model, or is that that's something else?
No. It's exactly that one. It's more or less the
so it's
background.
A different name for the same model.
It's not a different name. It's just categorizing what we are doing, because what we need to do in the system pillar is that we have a more or less a clear view of what has to be done. Not only there, these are examples. We should do the same for vehicles. We should have a product group structure then also for vehicles. There are already norms or standards that can help us there. So these are just examples, but these examples are already being put into productive systems. But the pattern that is behind could also be used somewhere else. So I think, yes, we are on the same page with that.
Yeah, maybe to add, the answer is yes. I mixed it up. Yeah, it's been fused together, but not the CCS TMS, as Ralph said, maybe under the ERA ontology part, because that's where they all come together.
So it's the use cases that are different. The model is the same.
Yes. Yeah.
So probably to just answer it directly. So what we are doing in the system pillar is starting from level 1 and going down with our models from use cases down to the level 5. And ULinks, so in ULinks, we are doing work on level 5 already without doing everything that would normally follow the SAM process. That is being done in the system pillar. And now we have tried to meet each other, and that is what I'm presenting here. And it should also show the systematic pattern in behind that could also be applicable then for vehicles. And that is what we see as our task here in the system pillar. Andreas.
Thank you. Just one comment. As you mentioned switches, I would like to recommend to talk to the guys from FP3 work package 10 and 11, where actually a pretty ambitious consortium, for instance, from First Alpine, they organize the equipment of 2 switches, real switches in the field, one in Spain and one in the Netherlands, I guess. The working approach is roughly they use as much sensors as they can attach to the switches, and the research organization in this consortium try to figure out what they can use for maintenance actions. So it would be interesting to get their approach to see what they do and bring these things together. Just a comment.
Yeah, thank you. So these models are extendable, and that is probably something that is very important. So this is where lots of people from industry, supplier side, have sitting together with from the IM side in this case, and they were all thinking about what is the minimum model we are having. And of course, this model will be taken and you can then say, I'm extending it. And I will come to OPC UA later on. That is a mechanism we are having there. So you can add, of course, if you have additional sensors, you can add them to the model. That is something that is wanted. Yeah? But the attributes we have already been defined in the standard, also from the semantical point of view. This, of course, must not be redefined with synonyms or homonyms or wherever. So that has been defined, but you can extend it. Probably this then is going to a standard in this kind of the ULinks standard, which is the interface specification SDIP. And that is an example for such a product group model, as we call it here. So that was just to give you an idea. So that is one perspective. Can I produce from the logical perspective or operational perspective? And the question from Ari was, that are not 2 distinct models. They are combined. And we are doing this with references that we can also very much use in the OPC UA world. We have lots of hierarchical references, which means an equipment has component, has component, has component, which is the hierarchical breakdown structure. But we are also having the relationships between equipment and product groups. For example, if you have a multi-object controller, then you have, for example, 5 switches on one equipment. If this equipment fails, then these 5 switches will not operate. So you need to know these object controller implements these 5 logical components, as an example. And so we have these relationships here that are not hierarchical relationships or references, that are functional references. Examples of that are implements references, or is part of redundancy group, that you know this is has a redundancy status, this component, and that is part of that redundancy group. And then this redundancy group can see, what is the minimum available? Do I have my minimum available? Very good. I'm operational. Or things like provides power to, that are also examples of functional references, not hierarchical references. So this is the way we are gluing all those both models together, that we get more insights. We are using the OPC UA protocol. It helps us a lot because it has information models. We can use these information models as companion specifications. And so we don't need to, everything you can just create the type we have been built. So you have a point, and then all attributes are already present. All the units, everything is there. And then you just have to go to the backend with your SDK for OPC UA and put in the sensor backend that the information is can be read from your component. We have supplier extensions, which means you can extend the model. You can just say, I have an additional sensor or more of that, and you put that into a type model where you extend the types you're getting from the standard. And then that is something you can express very easily. We have references, as I've shown, hierarchical and functional references. We have historical data access also built into the standard. We have subscriptions, which mean you don't have to clarify before when the data is being transferred. You can subscribe later on. So you say, I want to have this information, discrete information when it changes, or I want like to have this analog sensor when it is more than 1% updating or changing, or if you have a temperature changing more than 1 degree Kelvin or whatever. Yeah? That is something you can put into your subscription at runtime, and multiple clients can have different subscriptions at the same time in one OPC UA server. We have alarm and events, which is very useful for syncing who is doing what if you have multiple clients. The syntax is something we don't have to clarify because that is binary, very efficient, and already built into OPC UA. From the security side, we have sign and encrypt. Everything is built in, and we also have reverse connect, which helps us if you have a more safe part. Then you are not having any IP port you can access from outside. You are just going from the inside, from the safe part. So the server is doing a connection, and on that connection to a client, then the OPC UA connection can build up. We have roles, permissions that we need for many aspects. Can you do that? We can have method calls that we need for our configuration part, and it is very much supported by SDKs. Tane.
Yes, I have a question for you because I'm reading the title of your slide and I'm wondering, there's 2 ways to read it. Are we suggesting that all actual components of the system would implement OPC UA, or are we focusing it on the digital twin, saying that regardless of whether the equipment being considered as OPC UA support, for digital twin purposes and for integration into a digital twin environment, you are promoting to implement OPC UA, for example, an OPC UA client or an OPC UA server, maybe in certain cases, but in any case, regardless of the between quotes reality of the products, that's where I would like to get clarification.
So OPC UA is more or less a protocol that helps you a lot. We use it on the track side consistently in each of our standards. So we have product group models, we have the generic part of the models that has already been modeled, and the products are being made for the track side. So you can have you can connect an OPC UA server with a point, and then you have the model with the types instantiated, and you can read that. And that is, from our perspective, very powerful. That was the reasoning why we have chosen OPC UA. OPC UA will not help you in each and every question. So if you would like to read data from the field, I think, or from the vehicle in industrial environments, then OPC UA is, from our perspective, a very good choice. But let's compare if there are other standards. But I think this is the reasoning why we thought it was a good idea, and we still think it, because if you use something else, there is a lot probably you have to build on your own. And especially having information models, you define them first in all your groups. You're writing a standard, and then you just create from that type something in the namespace. That is a very, very powerful to have a standardized access to all your digital twin data. And that is something we just promote a little bit here, of course. And I know there are sometimes discussions in the vehicle side, for example, for train, bus, or whatever. And I think probably they can have a look also as well what OPC UA could do for them, and probably then it would be helpful. But it's, to be clear, that is, in the end, it's just a protocol that helps you a lot in bringing the standards to the field in a way that afterwards you can connect with each client to each supplier's diagnostic interface without having, everything is clear. That's it, yeah. So we think it's a good idea to use it.
Okay, understood. So I think it's more, I guess, it's a third version of my that I didn't consider. It's a general promotion. It's neither. So I know it's part of it's being used within the ULinks context, and it's consistently used. That's what you say, and there is value to it. There's no question about this. But I was thinking initially, I was thinking, because you said for a digital twin, I was thinking maybe you were saying that regardless of the reality of the equipment, you would foresee that as a means to glue digital twin together. So that's not what you're suggesting. Ultimately, what you are currently saying is please have a look at OPC UA, because it's a useful protocol that might have a fit, but it doesn't at this stage go farther than this. Because if we have, for example, a non-CCS, non-ULIX trackside component, okay, of whatever nature, you're saying there might be a use case for you to use the OPC UA for certain purposes because it brings you certain benefits. But you're not saying that at the moment all trackside components should necessarily implement OPC UA.
Yeah, we are promoting it in the standards we are building currently with ULinks. We are using it, and there could, of course, be a generic decision in going into that direction. But to be clear, I don't promote OPC UA for each and every problem. So what it can do for you is getting data from industrial environments. So you're getting data from the field, or you're getting data from the vehicle. But if you have another use case, for example, you're collecting data This is what we are calling the service function diagnostics. You're collecting the data from all these OPC-UA servers, from all the points, from all the level crossings, from all the interlockings or in the vehicle, from all the door systems. You're having all that data and you know who was the supplier from that data. And then looking at the European Data Act, you as a user, as an IM or IU, you might be willing to share this data with the supplier of that component. So the manufacturer of the door system should get his data to enhance its products. So how would you do that? And in this case, you will not use, from my perspective, OPC-UA. You will use them to get the data from the door system. But once you're having it on a centralized environment, then you would use something else. Probably that's something else. I have it here as a proposal. Yeah. So if you have these end-to-end relationships, then OPC-UA might not be a good choice. And then probably we have these international data spaces that have these decentralized approaches to actually solve such a problem. And that would not be OPC-UA. So I'm not saying I love OPC-UA, but it's not good for everything. Yeah, that is to be clear. Yeah.
No, but fair enough. Okay, so it's essentially what you're saying is there's a network effect to using a common protocol anyway. So it's a bit like saying in traditional networking, SNMP was giving you management objects that you could harmonize upon and centralize into an OSS. It's more or less the same story, and indeed, it's once you can harmonize on one thing, it's usually there is a network effect of using it more widely. So yeah, okay, fine enough. Thanks.
Yeah. Tiffany?
Yes, hello, Carl. Just a question, because I mean, I think there is also another layer of complexity, because you have just touched slightly the point in terms of actors, role exchange, logical level, functional level, some different level of abstraction, and it's clear. And even down to the protocol. So, I mean, you have the overall stack, I think, not when you have more or less a view in this point. But ownership of this data is still a little bit tricky. I don't know, probably it's not in the scope of this work, but you know, is a little bit, I mean, something that probably also from the system pillar I would like to have a clarification, not only from you, because in terms of ownership, it doesn't solve, let's say, some, problem at a very low level. I just use an example from the automotive sector, where you have a lot of standards, when you have a lot of ISO, you have a lot of protocols, UDS, WVP 2000, a lot of things, where everything is fine. You have your PC, you connect to your device, you use the protocol, you start the conversation with your device, but at the end, when you ask for some data, and you ask, for example, please let me know the status of this device, what I got back is a strings of 128 bytes, and with any possibility to understand what
magic
it is.
Numbers. Yeah,
exactly. So whatever, everything is standardized, and at the end, I don't have any possibility to understand. I mean, I know what we are talking about, but I don't have the real numbers. That's the point. And this is what is happening today in the automotive sector. So I would like to know if this problem is addressed or not.
Yeah. So in OPC-UA, you're defining the model. And once you have this data model agreed here, as an example, you can then put this into an OPC-UA model that you create the types, including each and every enumerator. So you would say, number 1 is status okay. Number 2 is something else. And number 4 is failure. And you do this for each and every. So that is completely modeled. And the meaning of each, what is meaning okay? What is fault? So when do I have to send someone? That is something we are defining in the documents. So you don't have any magic numbers, and you will put that then into a modeling tool in OPC-UA to actually creates that model. Here is a type space. So you have the object types here. And for example, this one would be the equipment type I'm talking about. And you can see that all the attributes are described here. Then you're using some data types. These data types are also described. So for example, if you have an enum here, then this enum, let's say activation state, you're reading 0, 1, 2, 3, 4. And you know 0, 1, 2, 3, 4 that is the meaning. And then there is an in-depth description of what that actually means, if you get it. And that is done throughout. That is modeled. And so you understand the data.
I understand. I understand the model. The problem that I'm saying that sometimes it's not clear, that I understand the data itself. Let's think about, and it's also written, for example, in the CCS model, where, for example, as far as I remember, in the equipment, when you have we have a power supply, as far as I remember. Now I just read some times ago. You have just this point where there is some vendor specific. What does it mean? That even if you know that you are in the field of something where you know the meaning, what you get back is 4F85. I know that it's power supply, I know that it's a voltage, I know that it is, but I don't know the number.
Yeah.
It's tricky, I know, but you can enter into this.
So as you can see, we have this SDI generic, we have the SDIP model, and now let's say someone as a manufacturer is using that, and he will extend this using the types and extend it with additional sensors. Your example, yeah? So he will put in an additional example, and he will model it the same. So you must have a description there. You must have a clear discrete item type and describe what number 1, 2, 3, what it actually means. So you will, as an IM or IU, you will not accept that this is standard. Okay, I understand what I'm getting, and everything else is magic numbers. Yeah, that is. No way.
Sorry, maybe it's a stupid question, but because I mean, this coming from a real experience, because it's exactly what is happening in many occasions when you have everything well described, but at the end you don't have any means to understand their value. And but if I like the idea that there is some must, so you must know, you must understand whatever you get, you have to be in position to, let's say, to translate, or let's say to translate that in something that you can understand. Okay, thank you.
That would be an example of such a model. You are seeing here the types. For example, that is a controller type, and we have also all the other types. And then in the objects or the OPCUA service, you are building the types here, and you have them in the equipment model and in the product group model. That is the specific extension here for SDIP point, probably being renamed as a switch. And they will have references, and then you will create these types or the extended types from a manufacturer, and these types will then be put into these folders, and then you can read the types and understand everything. That is how it's being made. And you also have the references in there. The problem is currently I'm a little bit over the time now. I have started a little late, but
just one question, Carl. This question is actually directed also towards Andreas and colleagues from DataSpace. So the data, because David touched the data now, the data that you said, for example, it's 45F, whatever it is, this is coming from the equipment outside. Is that correct?
What do you mean with the data for the equipment?
David made an example now of a power supply or a voltage power supply. You mentioned 45F something, and you said the person analyzing probably will use the model to understand what this this input is. My question is, this instance of 45F8, for example, it's a data coming from an asset that's outside. It's real. It's coming from assets to the server, to the OPCU. Is that correct?
Probably, I'm not sure if I get your question. So your
That I think the example is very generic. I mean, the example is very generic.
The point I'm coming back is to the data, because there is because in Klaus' presentation, unfortunately, you didn't get there. You mentioned data space as an alternative when OpenCU is not viable. But this will mean that the data space. The point I'm trying to get out, Andreas, is if there is this edge requirement to use the data space in this use case, because if the data that you are sending to the OpenCU server or this information, if it's coming from the asset itself, then it's coming from the stuff, from the equipment into that usage, which means the current data space, which is cloud, would not work. You would need to go down to the hardware. This is the question I'm trying to figure out.
You don't have to go down to the hardware. So what you're doing is you're reading the data from the assets. You're using OPCUA for that. Then you have everything in place. You have the equipment model. You have the logical model. The equipment model with the references is telling you which is a supplier of this logical component. And then you can use an interface, for example, like these European rail data space, or in vehicle sites, some people love GS1, but they are all the same. You have bilateral agreements that you can read the data. So you are just saying, I have data from your door systems, as an example. And then you're saying, I'm having data for your door systems. And then if we have a bilateral agreement, then you can use this standard protocol. And that would more be an end-to-end relationship. And you can use this as a supplier to download, I say, your data. You cannot download the data from any other suppliers. And that's just the use case we were having. We are having the same use case. I think later on we are talking about herd. And in herd, in the use case of a wayside management or a checkpoint, you're having data and you're reading it from a vehicle, probably from the checkpoint. That's something in the field. You're reading it with OPCUA, but you're distributing it end to end with something that you're having bilateral agreements, and then use GS1 or use this industrial. Everything okay?
Yeah, that's exactly the point I'm trying to understand now, because you said you need OPCUA to read data from the asset itself. So that means it's only post-processing that you use the data space for, which means then data space is not a substitute for OPCUA if I don't want to use it.
No. It's another layer.
You will never put an interface that everyone can access directly to the field.
I know.
That would be.
I know. Okay.
Don't do it.
I know, Carl. I just want to get that clear. That's the reason why. Because during the data space discussion, we have this edge requirement discussion. Okay.
OPCUA is accepted by, especially from the security standpoint. We had lots of discussions with the people clarifying security. We have. We have the identity and access management connected to the OPCUA concept. Everything has been already discussed with our colleagues from security. So, for example, if you want to execute a method in configuration, you're then going to the asset, I'm this user, then you're going to the EIM, then you get the roles, and then from the roles you're getting, can I an update on that item or not, as an example, or can I read, or can I do this and that? And that is heavily integrated. You are completely secured, updated, and that is built in, as you said.
Okay, thanks.
Just to conclude, this is why at the end, I mean, there is a thing I mean, data space is another time is up on everything. It's at the end of everything. If you want to do something more with this data, it's nothing to do with Carl has already described.
Okay, that's
but this is for me. This is for me is important because there is, I think, a question about ownership, because I still believe that there is something that could be tricky in order to do this. But again,
that is a different discussion in the first place.
Exactly.
In the second place, there might be, we have asked our colleagues from Europe Rail, because I'm a software engineer and I'm not a lawyer. Yeah? So from the European Data Act, the idea is that the user is in control. So if you have a smartphone, you're in control of your data you're producing with your smartphone. If you take this, if you're an IM or IU, you're in control of the data your assets are producing because you have bought it. You have bought the smartphone, you have bought everything else in your infrastructure. So as probably then you could be the user, and the user in this European Data Act can decide who is getting the data.
Correct.
And I assume that if I would be an IM, I would think it's a good idea that the supplier is getting the data from his assets, because then probably I will get better assets that are more durable or whatever, more reliable. And so I think that could be a good idea to share this data. But as I said, getting data from the field is one thing, collecting them, but then if you distribute them, you would probably choose another protocol.
Correct.
So I don't like this one-trick pony discussion that you have to do everything with one thing. That is bullshit.
Exactly.
Yeah.
But exactly, I understand it. But just for me, the problem is the following, because it's nothing to do with Carlos just explained. But if we want to have let's say, a soft relationship with the data space, then you know that in the data space there are two main roles: data producer, data consumer. So it means that this problem, let's say, this idea, this terms of ownership must be clearly known. But this is at the end of the process only if you need to share this data. It has nothing to do with Carl has already explained us.
Yes.
Why I'm saying this? Because in the automotive sector, each of us has a car. Your car produce a lot of data you are not even aware of, and you are not in control of that data. You are not the owner of the data. You cannot use this data unless you don't have a special equipment from the manufacturer. That's the point.
Yeah.
Yeah, but actually, this is a bit debatable, because if we take the example of car, technically it's your car. It's because of the current state of the regulation that it's not your data, but it could be your data. But just to say,
for me, a question mark, nothing else.
I think when it comes to OPCOA in an industrial context, I think there's a good case being made by Carl. But so if I draw again from telecoms. If you show me a G0B with OPCOA, I will be very surprised. And that's okay. Actually, it's not an issue. It's just that there are different cultures in different industries. And the more it's harmonized, it makes life easier for the IM in this context. Ultimately, when it comes to telecom, there's 3GPP, the TMF, telemanagement forums that have specification of stuff, which ultimately do, to a certain extent, the same role. And at some point in time, when you want to share that data with an external party, regardless of whether it's the manufacturer of the equipment or somebody else, whatever, then I think it's not the novelty, but it's an additional arrow in the quiver. I would say European data space could be a solution. So you have data, you associate policy to sharing and exposing that data, and people might be able to consume it using the data space. But obviously, people have been sharing data without data space in the past, and they will continue to do so in the future. It's okay. It's not an issue. So I think the importance is the more we harmonize, in any case, around a common way of doing things, the less variation thereof. And normally, it should reduce costs of actually processing that data in the end. But it's just Nobody forces anybody to use the space, at least until now, but they would be encouraged to do so because it gives a common framework to synchronize around, I would say.
I really like this discussion, but I don't want to be hated because you don't get any coffee.
Yes, that would be my question. Sorry to interrupt. I think it's very important to have this discussion. It's really interesting, but unfortunately, our time is a bit limited. And the second half of the day is already planned for other topics. So we still have the presentation before the lunch break about HERT, European Railway Diagnostics from Emilia. And then there's a second part planned for you, Carl. Maybe we could have a very short break now, only 5 minutes to take a coffee, and then continue with Emilia's presentation and use the rest of the time before the lunch break to continue the discussion, if you agree.
Yes, perfect.
Okay, then
Yeah,
see you
it's
back in
absolutely
5
okay
minutes.
for me. I will speak with a double speed.
Okay, thanks a lot. So see you in 5 minutes then. Thanks.
Okay, see you in 5 minutes.
Carl, maybe you can put the ITSA slide on the table, on the screen, that shows that European Rail Data Space is just it's ITSA. There is nothing rail specific on that.
So I can show that. The good thing, yeah, it's not a railway specific standard. This ITSA, international data spaces. So you can so this standard is
perfect.
And this picture is not railway specific, and it has been adopted by Europe as an Gaia X project for the railway sector, and there it is called European Rail Data Space. But that's the same. So all the connectors are being the same. It's not specific. And to actually having these end-to-end data sharing needs, be it probably for herd applications, for wayside monitoring systems, sharing the data with vehicle owners or whoever, and also vice versa, that you have continuous track monitoring data, sharing it with EIMs, or even if you are in one sector and you're saying, I'm having data from switches from a specific supplier, then that these data is being shared specifically with this supplier. That would be the same use case. And probably that is one solution, doing that on in a way that has been technically already defined as mature, and it seems to be already supported from many sides.
So I think everyone is back from the break, more or less, and we could come to the next part of this digital twin session, which is about the work in the system pillar on the European railway diagnostics, the task 5. And Emilia has prepared a presentation for this. So I would like to give the floor to Emilia. Thanks a lot.
Thank you very much. Please let me know when you see my screen.
Yes.
It's fine.
Okay, fine. Good. Then hello, colleagues, and thank you very much for the opportunity to talk about herd and the possible interaction between herd and the digital twin. I will try really to shorten my presentation as good as I can, and I will start with overview, which maybe some of you some of you already know. This overview shows that the system pillar is in the role of coordination of inputs for communication and to generate standards, respectively specific documents for the integration of inputs to the EU rail system. It is, of course, an iterative process between the innovation pillar and the system pillar, where the system pillar gains information from the innovation pillar about the expected outputs in different innovation pillar flagship areas, and also supports the innovation pillar with these standards and specific documents. So I see that this clicking does not work very well. Yeah, okay, now. Really on a very, very short notice, who is hurt, what is the purpose, the objectives, and what are no goals and what is not in the scope. As you know, HERT has started approximately 1.5 years ago, and in October last year, 2024, we became task 5 in the system pillar. So the purpose is to ensure the design of a standard procedure for harmonization of the European railway diagnostics, and we focus on a proven harmonized use cases set and generate functional specifications for the diagnostic data exchange. In my further presentation, I will show you 1 or 2 use cases we currently work on. What we do not is to work on standardization of measuring methods, diagnostic systems, or analytical calculations. We do not care for the data governance. As a data governance, the IPRs, or, for example, what are the legal regulations in the data exchange between the data user and the data supplier. Of course, for us, the contribution of this harmonization and the benefit of this harmonization, especially the benefit for the data user, is in the focus of our work, but we do not generate CBAs, the cost-benefit analysis, but we support with generating structures which will help to prepare cost-benefit analysis for the data user. So the next slide, it is also a global overview about the motivation of us. And how we want to contribute for achieving the objectives of the single European railway area. And most of us, we want to contribute to cost and time savings, to ensure interoperable and seamless rail transport. We want to support the competitiveness, and in collaboration with the innovation pillar, to help to boost the innovation in the European railway area. In our work in the last months, we have recognized that collaboration is in the center of the success of our work, and of course not of our work. And for that, we want to promote the collaboration between the key players in Europe to efficiently exploit the synergies, the relevant synergies, and so to gain much more value from the railway diagnostic data. So this collaboration, as I have mentioned before, is very important for us, and therefore we have decided this year to focus not only on how we can share our achievements, or how we can disseminate the outcome of our work, but to strengthen the collaboration with all areas in the innovation pillar, but also, of course, in the system pillar, which can lead to gaining more diagnostic data in a harmonized way, and finally to collect more connected information, and then to gain additional information about the railway assets. We have tried to understand what is the digital twin. So please excuse me, if I'm talking about the things which are pretty clear for everybody of you, but for us it was very important to understand what is the digital twin in the definition of the innovation pillar. And this is what we have found. So that it is a copy of or a screenshot of a presentation made by Andreas Heckmann last month. And in this presentation, Andreas said that the digital twin is a virtual representation able to imitate the behavior of a physical system during the span of its life cycle. So virtual representation, that means that with the help of digital tools, it is possible to generate a digital mirror of some railway asset. It could be part of the train, maybe it is a behavior. So to imitate the behavior means that this model reacts on external influences, on some events, and imitating this behavior will predict the reaction of the virtual representation of this asset. Of a real physical system means that there is a need of physical measurements with the real data, and this real data is then implemented into the model to imitate the behavior of the digital model. And then during the life cycle, it's very important for us as HERD, because we are also focused on delivering information during the whole life cycle of the physical system. Furthermore, Andreas has said in his presentation as a more practical specification that the digital twin is a virtual construct that incorporates data, models, algorithms, software, etc. It's linked to real data sources and is capable to be updated based on the changes in the input information and the algorithms which are part of this digital twin. And finally, it is tailored on a specific use case and its objectives. Therefore, please give me the chance now to show you how HERD and the digital twin are linked with each other. Concerning the life cycle, digital twin mirrors the behavior of the variable system during the life cycle, and HERD supports with the harmonized diagnostic data as a part of the description of the railway physical system helps and supports to describe this behavior and the system during the life cycle. This is the first point of interaction. The physical system mentioned before. The digital twin means a virtual constructed associated to a physical system. HERD focuses on the real railway system as a physical system like wheels, doors, pantographs, brakes, bogies, as well on the infrastructure like track or catenary. The real data sources, the second point mentioned in the description of the digital twin. The digital twin is linked to our real data sources and capable to be updated. HERD focuses on harmonization of the real data, which describes the asset condition, and these data are regularly updated via the harmonized diagnostic database, which we are currently working on. And last but not least, the use cases. The digital train is tailored on the specific use case and its objectives. HERD as well focuses on proven specific use cases set with harmonized diagnostic data and defines a specific harmonized diagnostic data interface to support to achieve the specific objectives of this use case. This definition of the harmonized diagnostic data interface we have generated during our workshop last year, and it shows what we want to achieve with the HDDI. This HDDI can be implemented at different levels, more or less 2 levels, because for us as HERD, it is important to have crystal clear defined data user and data supplier. So as we take the example which I will show later on with the wheel set, then the wheel set data is mostly transported to an infrastructure manager, which later on sells this data to the final user, which is railway undertaking or vehicle keeper. And so we would have 2 possibilities for harmonization between the supplier and the infrastructure manager, and or between the infrastructure manager and the final user. This harmonized diagnostic data consists of asset-related data, so real data, the measurement data of the parameters of the specific use case. So these are the measurement data of the parameters in the specific use case. Then the diagnostic data represents the time-dependent condition So will be an input for the digital twin model. The specified metadata will deliver additional needed information to show how this model will react and will help imitating the behavior of the digital twin. And finally, and this is our main target, we want to support to make the asset management much more efficient. That means linking, but this is not the herd, this is the data user, who will be able to link different informations about the, for example, the maintenance instructions, the condition-based information, the planning information about, for example, where this asset, this train will be at such moment, and how this asset will be managed in the future. So this connected maintenance will definitely help to improve the planning for the assets and will make the asset management much more efficient. So the purpose of HDDI is to ensure this compatibility of the use case specific data generated by different systems. That means if we collect information from different suppliers in different countries, it must be possible, first of all, not to generate for each supplier a separate bagel fish, which translates the information into a format which could be later used, but to have a unified, harmonized format of this data. And it should help the data user owner to collect as much as possible information about the own assets. In HERT, we do not focus on systems which are related to safety relevant systems like CCS, DMS, or ETCS, but on the assets in the train, respectively, as I have mentioned before, on the track without a cantilever. So, from our point of view, the digital twin needs real data sources to operate, and HERT can provide harmonized diagnostic data for various digital twin use cases. One example, yeah, of course, wheel sets, and today there are many different data sources in different formats and also in different data quality for one and the same intended use. And with HERT implementing the HDDI, we want to standardize and harmonize this diagnostic data and to ensure this compatibility, which I have mentioned before, and gaining this information, this additional information and more information will lead to multiplication of the gained benefits. For that, not only the owner will have a profit, but also the infrastructure manager, all in this railway system will have a profit of it, because, and this is not needed to explain it, damaged wheels will damage the infrastructure, and in opposite, in vice versa too. Yeah, here are the main points which I have already mentioned, that many European infrastructure managers operate with detectors and with systems, and the systems generate different data with different data in different formats which are not harmonized. And this use case, which are currently working on for harmonization and generating the HDDI, targets the challenge that currently there are no standards for this diagnostic data or an interface in place to make this the measure of wheel condition information available for all for different users which can consume this data from these systems. what we have learned and what you have understood is that there are many, I will say, teams who work on standardizing of interfaces, who generate interfaces like the SDI for the CCS. There are already standards, so there are already available informations and also standards, but it seems that no one of them covers the full needs which we intend for. And what we do now is to investigate these available systems, available standards, or drafts of these standards. And if we recognize that some of them in a very high degree covers these needs, then of course we will take these standards. So we are not interested to develop something completely new, absolutely not. In opposite, we want to use outcomes and available information, standard structure, whatever it is, and to finalize it for the specific uses in the specific use cases. So what are the harmonization challenges in the ERGU today? What we have recognized, so this is in general the diversity of national regulations, which complicates the creation of uniform framework. Then there are various implementation practices. Some systems are advanced technologies and other are based only on basic parameters. Then there are inconsistencies in the data formats. Of course, there are also constraints from operational and financial nature, which generate additional but significant barriers, especially for small organizations, which struggle with high cost for the modern systems. And finally, to ensure the consistent and reliable data quality across the different systems and providers seems to be very difficult today. And finally, there is a need, and this is a challenge, of extensive coordination among the diverse stakeholders because we have recognized that there are different interests, priorities, and also different technical capabilities. So what are our lessons learned until now? Harmonizing the diagnostic data to be able to be usable without barriers, and here we focus on existing measuring systems. So here we would like to intensify our collaboration with flagship area 1 in work package 27 and 30, and to create a unified process of harmonization and apply. So we're looking for an immediate way to exchange the data according to clear and simple rules for everybody. And here, once again, to collaborate, to intensify our collaboration with flagship area 1 and work package 31. And in the picture, it's very, very simple, of course. We have on the one side flagship area 3 and flagship area 5, which work on how to generate the data using video gates, for example, just as an example. So this is a real asset diagnostic data. And on the other side, we have flagship area 1 with the federal data space, which will regulate how the data can be exchanged between the data user and the data supplier. And we as HERD would like to support and to offer a harmonized diagnostic data interface so that this data exchange is made with a minimum data loss, I will say, no, minimum data effort to translate the physical output from the systems and make it readable in a unified format for the data user. And I repeat myself, no system will be able to do it without cooperation among the stakeholders with an open approach. And so we want to proceed and to do it without excuses. So this is one of our main targets for this year. And this is my final slide. Just as idea and a proposal for a possible way forward between the digital twin and HERT, that it will make sense to align on the specific use cases, because there are use cases in the digital twin and use cases in HERT too, and to align on the purpose and objectives of these use cases, to align on the description of the physical system concerning the parameters, static, dynamic properties, events which influence these physical systems and influence their behavior. And finally, also on the harmonized diagnostic data concerning the methods of update, the quality of the data storage, etc. So that was my presentation. If you have any questions, please don't hesitate. I will be happy to answer them.
Yeah, thank you very much, Emilia, for this very interesting presentation. And I'm pretty sure there are questions and room for discussion on the collaboration between System Pillar and Innovation Pillar. Ralph, I think you were the first one. Oh, Pierre.
Yes, actually, if you can put the presentation back up, I think that would be nice, Emilia. But thanks for the presentation.
Sure.
I posted, I didn't want to interrupt, but you clarified during the presentation. So there is the harmonization of the interface to exchange data. That's one aspect. And then there is what is being exchanged. And then from what I understood of what you explained, indeed, you also intend to say, so if we take a specific case of something on the rolling stock, let's say the pantograph or the wheel, there you intended to harmonize also the description of the condition of the asset. So it's also going to be harmonized, and as such, you would probably have, I would say, a profile as associated to each of the assets. So essentially, on your last slide, the second bullet point is probably on a per asset basis, a description of the asset according to specific characteristics that would be monitored, and that would be transmitting using the HDDI, right?
I have recognized 2 points in your question. The first one is to harmonize the description of the condition of the assets. This point would be the perfect, but it is very difficult because the different data user have probably different needs, and so they have different models for the condition of the assets. And for that, we do not focus on that to harmonize the description of the condition, but we want to have an interface which is capable to cover the needs for different condition descriptions. And so, we are fully aware that it is pretty complicated.
Yeah, that's a reason why I was asking the question. It is complicated, and especially I think what we need to consider for a pantograph is going to be vastly, obviously different from a wheel. But so in practice, then what would be exchanged then? Let's say for a pantograph, can you elaborate what you think we could exchange just to materialize it a bit more? Just one follow-up question also on the only thing I was surprised about in the last bullet, which is why I'm taking advantage of combining the 2 points. Data storage, I'm not sure why it's popping up, because that sounds more like a really implementation choice, I would say. I'm surprised you were raising data storage, unless maybe it's related to encryption or things like this that you had in mind, but it's not related to the first point, but just in the interest of time, I'm combining the two.
I will answer your last question, why data storage is mentioned here, because in as we have started with HERT, and this is also on the first slide, we said we do not care whether data, the diagnostic data is storaged. We don't care for that. We care only for the interface. But now we see that the data users are interested and they are asking us, and the data supplier too, okay, how we can exchange the data. So if there is a digital twin and we support this digital twin in the specific use case, then the colleagues or the consumer of this digital twin should know where this data is stored. So HERT, and I would like to say it here crystal clear, HERT does not care for the data storage, but we should align on that. This
okay,
is
I understood that part.
is
Okay,
mentioned here. We should align on that. Yeah.
No,
so
it makes
not
sense,
to
yeah.
say,
Okay.
okay, we send it by SMS or we will write an email and then we have federal data space. You know, we should align on that.
Understood. That's clarified. Okay.
Okay,
On the previous
good.
point, so I guess the
Pantograph, yeah, this is not my expertise, the pantograph. I'm sorry.
no, even the wheel,
so
it's just the because I think we all agree on the fact that it is challenging to describe. Whenever you describe the condition of something, then you also will come with the interesting questions about the accuracy, I would say, of the measurement
Absolutely.
of what you're describing. So it's a problem in itself. But that's
Yes.
where because you could envision that using HDI you would send between quotes the raw information of a sensor measuring something, but in that case, obviously, the receiver of the information on the other end needs to be able to interpret that data correctly, otherwise it's becoming useless. At the same time, so that's why I'm trying to understand what if we have already a thought about the nature of what would be exchanged in some of these use cases, whether that's for wheel or for pantograph. I'm probably less of an expert of the pantograph than you are.
Yeah, no, I fully agree with you, and we totally can agree on that. That not only the measured value which is delivered, but also the additional information about precision, about accuracy, about standard deviation, etc., should be also delivered, and this information should be available for the data user. And this is exactly this is the point of a really difficult point for the harmonization, because I would say just the number 5 from system 1 should have the same meaning as the number 5 in some other system. And we're pretty on the beginning, but I fully agree with you that this is important point, and we consider it 100%. Yeah.
Thank you.
Carl, please.
Yeah, yeah, probably. I think there are not so many differences from my perspective between what we are doing in System Pillar on diagnostics and what we are doing on harmonized diagnostics in Emilia's work package. So if we look at what we do, so we actually get data from elements with a product group model or with an equipment model. And this is being collected. And that is something we call service function diagnostics, because that is a very old name. Sometimes it's called an MDM function or whatever. So it's a historical name. There is already the historical data access included. And from my perspective, for example, the wayside monitoring systems already have an OPC UA interfaces if I look to the current supplier structure. So they could work as an SDI compliant element, bring up their information with OPC UA, and then this information could be shared, for example, with rail data space or as we've seen in the example or with the GS1 standard. I think then this would be very much similar to each other. So we could use the same parts, which then would mean that we need a product group model for a wayside monitoring system or checkpoint system, or that we need the same thing for the continuous track monitoring part, also a product group model. And as Emilia said, there are these product group models. There are a lot of them already existing. So DB, for example, has made together with SNCF a product group model from some portions of the checkpoint data. And in SD1, which is the data package, we already have a description of the topology, which allows to align characteristics to the track that you are measuring. So, for example, if you're measuring the longitudinal height as a continuous track monitoring or anything else, then you can use that data model as a product group model to actually get the data from there. So I think we have lots of similarities here. So if we take the chance to have this same breakdown structure to digital twin, physical model, and then the logical models, the product group sets, then I think things to me are very similar.
I don't know if it's Ralf or Wassim. Okay. Wassim, please.
Yeah, okay. I was thinking on the same lines because these both, I mean, they both have the similarities, and I think they both are referring to the rail data space. But my question would be, are we talking about the streaming data here? Because that's the dynamic properties which you mentioned, right? I was thinking that because they should flow as a stream from point A to point B, because when we talk about digital twin, that has the same logic, and here as well we have the same logic that this data, this diagnostic data should actually be dynamic, and plus it should be streamed on a continuous basis, right? Is my assumption right?
Yeah, it's right. Yeah.
Okay.
And
okay.
the advantage of these HDDIs, let's say we have cargo train, so a freight train, which drives from Sweden to Spain, from Germany to Romania or Bulgaria, and collects and we should not forget that the infrastructure in the different countries is completely different from the quality. So if we have maintenance instructions which tell us that after 30,000 kilometers we should do this and that, and in 5 years we have to change the asset X, the behavior, and this is the interesting thing with the digital twin, will be completely different if this train is mostly driving in countries with not so perfect infrastructure, but in other countries. So traveling from the north to the south and the east and west, and having this HDI, and I'm not talking about tomorrow and next year. Our vision is in 5-10 years and more. So we want to have a unified, harmonized diagnostic data interface, which helps to collect information from different countries and different suppliers. And I'm absolutely sure that the countries which are not developed so good today will make these steps in the next year. I know the European Commission supports with unbelievable money to improve the infrastructure and to make this transport much more seamless. So having this data from different suppliers in different countries will help the data user to have much better asset management. And in this process, we have the digital twin. Because the artificial intelligence, the data management the data processing and the processing of big data, this is our future. So we will have this planning and the management of the assets based on these virtual models, which will their life will be the consumption of reliable data. And the reliable data comes, of course, from reliable systems and harmonized data. So. Okay, I see that there are no other questions. Thank you very much for your attention and also for the interesting questions. Yeah. Karl, I think you're the next. Or we have a change in our agenda.
From Ralph.
Yeah, one question. This is sorry for that. This is more from a what Wasim brought up. Are we really prepared with OPC-UA to support terabytes of data streaming there from all kind of sensor systems that may produce terabytes of data? Is that the way forward?
I don't know who you're asking.
To whom the question is going,
Yeah, the one who can answer it. If you feel confident, Karl. And I mean, OPC-UA you proposed, and the architecture you have shown for the diagnostics very much recommend to go this way. Wasim, I understood things about streaming. That means sensor data in terabytes.
Yeah.
And then I'm a little bit reluctant when it comes to OPC-UA information models. Goes that very well together, or is it because at the end you need somehow also aggregation and analytics in this process when going northbound? Yeah.
So it's answering the question. So it does. The good thing with OPC-UA is that, for example, compared to the HTTP protocol, that has lots of overhead. So if you would like to send a small amount of data, new temperature, and you have to establish a new connection, establishing the connection, this small amount of data, new temperature, and then the connection is gone. And then new value, you're re-establishing it, and so on. So that is something why IoT protocols are not using HTTP, for example. OPC-UA is an IoT protocol, and IoT protocols do the following thing. They establish a connection, so you have an established connection, so you don't have to do it each time. And on this established connection, you are sending the small amounts of data, so you don't have the overhead. You are just having a binary protocol sending these very small amounts of data. So it is exactly made for this kind of thing. The one thing I would not propose to have it is for camera data, for example, because then you don't need TCP, you need another base protocol. But for everything else, OPC-UA for transporting data in a secure manner with an really IoT protocol, with an established connection that is transporting it, there it is a good choice. It also has some means, for example, that you have numbers on each package. So you exactly, if you lose data, you get package number 1, package number, now I get package number 3. So I have lost data. And you know that, and then you can get data with the historical data access, loading the data. You don't need to have the data at runtime. You can subscribe to it, which means you look at probably the top level data, the statuses, which are cascaded in the hierarchy. And if something happens, then you change your subscription and you see all the data points that explain the situation to you. Even there, you can reduce your bandwidth needs. But from the bandwidth itself, since it's a binary protocol on the protocol level, it's already very, very optimized. And it is exactly for this need. Yeah. This is how I would explain why OPC-UA is a good IoT protocol.
I'm sorry, I see there is another question too, but yeah, I have planned in this lunch another meeting for me because today I have a very urgent topic to close. So at 1 o'clock, this meeting will start. So I have to leave in 3 or 4 minutes just to switch a little bit to the next meeting. So I will be happy to answer the last question. And then please excuse me, I have to leave and to join the next meeting during the lunch.
Yes, thank you, Emilia. In fact, it's not a question, but it's a comment on the question raised by Ralph earlier.
Okay.
We must be sure not to think or to be tempted to think in having one big God digital twin, one big God model, etc., because it's always the same kind of failure that looms. To take a very simple example, I mean, if you have terabytes of data, you are lucky. We'll end up with maybe petabytes, okay? So just a concrete example. We suppose we monitor the temperature of axle boxes with whatever means, trackside. I know it's a bit antiquated, but just for example's sake. Then you observe them, and you observe the temperature of the axle box opposite and the evolution of the temperature of the axle boxes. I think no digital model in its right mind will be interested in getting all these data flows in real time and try to think over it, because you will delegate, of course, that aspect to maybe a smaller digital twin, only reasoning on temperatures of axle boxes, and finally, maybe even every now and then, raising an alarm, and then you send that to the operation part. So, sorry, that sounds very naive, but I think in terms of architecture, what I don't see right now, but maybe it will be subject in the future, is how we make sure that there is no big basket in which we pour every little piece of information and hope to get clever out of it, because things might work better in a different way. I'm sure you already reflected upon it. It's just that it didn't spring immediately into the eyes by looking at the different slides.
Yeah, I agree with you, and therefore in the last bullet I have, it's not shown anymore. I have mentioned that we have to agree on the methods of update. That means also the sampling rate and which information at which moment is needed. I fully agree with you, and the target is not to generate data, but to generate information. And this information can be only collected if we have the right data at the right moment. So I agree with you. Good.
Okay, thank you very much, Emilia. In this case, if you have to leave, I think the discussion was a very good basis for future exchange and collaboration. And I would say we are approaching the lunch break. And yeah, Ralph, there's another comment.
Sorry for that, Emilia. Just a last second comment. My learning or my takeaway is that we urgently and massively need to work on these product group models, as they seem to deliver what you request in task 5. So I would then be very much interested also in learning how the innovation pillar, especially with innovation projects, can contribute to this task, producing product group models that are contributing to the objectives of task 5.
Yeah, we are lucky that you're Alpha in our team in task 5 and Carol too. So we have very strong actors in task 5. And I think, we will set up the right step for the next time. Now I have really to leave. Thank you so much, all colleagues, and we will see later. I will join. When do you plan to start with the next presentation?
I would say we make maybe 30 minutes break and try to continue with the agenda as planned at 1:30.
Okay, so I will do my best to join you. Thank you very much. Have a nice lunch. Ciao.
So maybe before we come to the lunch break, Pierre, if you have a point directly related to digital twin, you said concerning the TSI request, then maybe you can put it.
It is related. Thanks, but I think we can do it after the lunch break.
After
It
the
doesn't
lunch?
really
Okay.
matter. We'll
Okay.
just incorporate it into the discussion, I guess. Yeah.
Okay, perfect.
Thanks.
Yes, then I would propose that we start with the lunch and that we try to continue as planned at 1:30, so we don't lose more time. Thank you very much.
Thank you. Bye-bye.